coming back to my question about how many servers does it take to process that video-intensive web service in a composite kind of workload, we're talking about using significantly fewer servers, in this case 35 one-socket servers versus almost 49 CPUs for AMD, which could be translated into roughly 25 or 24 servers and in 2 sockets, right? Or 81, 40 servers for the Intel case. So you're using about 2.3x less, more. You're getting 2.3x more performance per rack, which is going to translate into energy. How much power is consumed by those servers to do that workload? And in this case, we chose 1.3 million requests per second because it fit into one rack having a power budget of somewhere in the 12 to 13 kilowatt range, which is right in the middle of the road of most racks in the world today. Probably 80% of the racks in the world today are probably running somewhere in the 10 to 15 kilowatt range. And so that's one of the reasons why we chose that number, because you can fit these servers into one rack, and you're going to consume a heck of a lot less power, almost 3x less power, and a third of the space as well, because once you've spilled over that power budget, every rack in the world today has a power budget, then you've got to go into the next rack. You've got to provision into the next infrastructure. Once you provision into the next infrastructure, you take on a whole lot more space. You take on a little bit more overhead for running the power and conditioning the power and managing and networking and everything that goes into that rack. So 1/3 the space, 1/3 the power, almost 3x the performance per watt in this particular composite example. And that is the power of using this type of efficiency. Someday I'm going to update this whole analysis to include the actual NETINT example, because if you put the NETINT video processing power efficiency on top of these processors, you're going to get an even more beneficial scenario, because again, you're taking all of that video workload and offloading it to an even more power efficient element. So that'll be an exercise for the future.